Okay, so the tracker is just about finished. Okay, so it has finished and it took 308 seconds. This is in milliseconds, so 308 seconds or approximately 5 minutes. So it pops up a whole bunch of windows here, and the first window is the track navigator. And this is the window that you'll be using a lot to determine which objects have been detected, to determine if they match up with a known asteroid and that sort of thing. So there's also a lot of columns here, and so it's a lot of information. Now, what you can do is you can go ahead and click on a track, and that's going to bring up the image viewer, and you can of course zoom in on that. And if you want to know what it looks like when you go from one position to the next, there's the track positions window here. So what that does is I can actually scroll through, and you can see the object is moving, and so that gives pretty good confidence that this is a real object. In fact, I can go ahead and turn off the crosshairs, and again you can see that a little bit better. You can also use this window to perform stacking of the object. So if I wanted to, I could hold down the shift key and then hold down the arrow key, the down arrow key, and I can select each position to be integrated into the stack. So this gives you a nice way to see that the object is stationary while the stars are streaks. And so that's just another tool at your disposal. So okay, I'd also like to go ahead and point out that the right ascension and declination, these coordinates that you see here in the position window, these are rough estimates of the position of the object. In other words, they are computed from the track of the object itself. In other words, we have this change in x, change in y, and so these are computed values based on the movement of the object in the track. So you would not want to submit these as observations, but you could still use them if you wanted to. You could use them to determine if the object is within the window of another known asteroid. So anyhow, they serve a purpose, is what I'm getting at. But again, you wouldn't want to use them as official observations. So I will, however, explain how you can create good observations in just a bit. So again, let's go back to the track navigator window. We can load up the MPC orbital database. So this is a file that has 780,000, I'm sure at the time of this video it will have even more asteroids. So it loads this database of known asteroids, and it compares them with all of these detections. So some of these columns have now been populated, and one of the columns in particular is called object distance. So this is a distance from the detection to that of a known asteroid, and it is in arc minutes. So if you see something like, in this case, 0.04 arc minutes, that's a pretty good indication that the asteroid that it has found in the MPC orbital database file is actually associated with this detection. And again, you can verify that if you were to go into the MPC website, the minorplanetcenter.net, and you fed these positions into it, it would tell you that yes, these would line up with this object. So, but this is a pretty good way to very quickly go through your list of detections and say, hey, yeah, I don't care about these are already known asteroids, for example, but maybe I might care about this one because the closest asteroid is 5.5 arc minutes away. So maybe this is a new asteroid that's not been observed before, for example. And so what you would do in that case is, to determine if it is actually an asteroid, is I have a window here called Track Combine. I like to turn up the brightness all the way, and you can notice that it is a nice presentation in the median filter. So it looks like a nice object in the median filter, and when I go to the average combine, it remains as a nice clear object in the average filter as well. So it's not like we got some pixels off of a star and it had some noise and somehow managed to make it through the filter. Now this is actually a real asteroid, and you can see it has consistent value above the median from one frame to the next, so that's also a good confidence booster. And finally, since it is bright enough, we can also inspect it in the image viewer. So I can go from one position to the next, and you can see that indeed this is a moving object. And so this is definitely an asteroid. Again, I can center on that if I want to. And so this would definitely be something that would be of interest. So, and again, if I wanted to, yeah, I could go ahead and do this, and that sort of thing. Okay, so that works great. So let's suppose maybe I might want to actually create observations. So that's the key thing out of all of this is, yeah, maybe I've discovered something, or it's something that I want to create observations on. So how do I do that? So first thing you want to do is, again, back in the Track Navigator, you want to load star catalog. So you can do this in one of two ways. You can do online access, or you can have your local copy of the catalog. So in this tutorial, I'm just going to use the online access. So it connects, it downloads, and it performs calibration. So this is both the position and photometric information. So we now have magnitude information, as well as accurate astrometry as within our grasp as well. So if I go back to the image viewer, you'll notice now we have these blue rectangles. These correspond to stars in the catalog. So it's good to know that they match up with the stars in the image. So that's good to know. But finally, I can go ahead and go back to say I wanted to create an observation from this first position. So I click on this first position. I could have clicked on any, but say I click on the first position. I can zoom in a bit and I'll go ahead and bring up the crosshairs. And you'll notice, again, this is what I was saying before. The position here, it will not necessarily center on the peak pixel, okay? So again, it's based on the movement of the track. So to get it centered on the peak pixel, sure, you could manually do so potentially, but you can also just double click. So when I double click on the peak pixel, then the software is going to go ahead and move to the pixel having the highest value in that region. Okay, so so now it's centered on the peak pixel, and when you click on Create Observation, the software is going to run a centroid algorithm. So it's going to determine the exact XY center of this object, and when it does so, it's also then going to determine the right ascension declination with respect to that centroid. So we could click Create Observation, and it has gone ahead and done so. So this brings up a window here of observations, of which we have one at this point, and I now have the precise, it's at least sub-arc second precision. I have now that position and the right ascension and declination. I also have magnitude, and I have the date. So if I wanted to, I could view a formatted report, and this would be one observation. And if I wanted to go ahead and create more observations, then I go and I say, okay, let's go to another position, go ahead and double click. So it was already centered on the peak pixel. Click create observation. I now have 2 observations. Do it again. I now have 3, and maybe we'll get this last one right here if it's any good or not. So yeah, it's right. If I were to use that very last one, it would be right next to a star. So maybe I don't want that one. Maybe I want this one, for example. So I would add that as an observation. So once you have the observations you want, then yeah, you could actually submit these, and but of course you'd want to change the name of the object first. So the software gives it a default of unknown, so unknown number 1, and so it's your responsibility to give it your own designation, or if it is actually associated with a known asteroid, then give it the designation of that known asteroid. Okay, so that wraps up that portion of the tracker. So you know the key points of how to go through the tracks that were created, and again, these are sorted by quality. So essentially what that means is that as you get farther down the list, then the tracks become less and less likely to be true detections. Now, it came up with 24 tracks here. In this particular data set, there are about, I want to say, 12 true detections. And so the ones that are down here at the bottom, they're actually just duplicates of these good detections, just because it found another way to arrange and stack the images that formed a detection, but anyhow, it was not as good quality as the earlier one. So how do you know when it's a duplicate? Well, this has the same label, the RZ92, as this one, and it's certainly, that's another reason to have this window here, is that when you look at the median combine, it's kind of a smudge. It's not a very good detection at all as compared with this one. So this is a nice, good detection, and this one is not very good at all. So I would never use this one. And so yeah, this one is a much fainter, smaller, so it's also not quite as good. So anyhow, as you work with this program, you'll start to get an idea for what is valid, what is not, and there's lots to learn about it. But hopefully, this tutorial provided you with a reasonable start at how to use it. So that's all I have for now. Thanks for watching.